So why did India's car industry actually work? Was it cheap labor? No, Vietnam has cheaper labor and doesn't have this. Was it government policy? No, India had government policy for everything, and most of it failed spectacularly. Was it Maruti Suzuki? Maruti arrived in 1983, but the ecosystem it plugged into was already 30 years old. Was it domestic demand? China had more of it and built their industry differently. Was it engineering talent? No, India's engineers were busy going to America. So what was it? What was the actual thing? It was trains. It was 1853. It was the British laying iron rails across a subcontinent and needing anyone, to maintain them. And the workshops they built to do that, dirty, loud, unglamorous railway workshops, quietly became the most important manufacturing institution India never knew it had. What if I told you that India building a world-class car industry had almost nothing to do with cars? It started with trains. In 1853, the British laid railway lines across India, and to maintain those lines, they built workshops. Metal fabrication workshops. Workers from those workshops did not disappear in 1947. They became the seed of something much larger. Then, Tata Steel arrived in 1907. In Jamshedpur. A full 40 years before independence. India had domestic steel before it had a democracy. Ecosystems need a floor. Steel is the foundation of manufacturing. Post-independence, India made a decision viewed as economically illiterate. It slammed the door on imports. 100% duties. Foreign exchange controls. You couldn't bring a foreign car in without basically bribing the government. So Hindustan Motors made the Ambassador. Premier made the Padmini. Both were licensed foreign designs, frozen in time, made entirely in India because they had no choice. Here's the counterintuitive part. That compulsion created something real. Suppliers had to exist. Not because they were efficient, they weren't, but because they were the only option. Clusters formed in Ludhiana, in Pune, in Faridabad. Foundries, pressings, wiring harnesses, rubber parts. A generation of workers learned manufacturing not because the market rewarded them, but because the government left them no alternative. Then 1983 happened. Maruti Suzuki. And this wasn't just another car, this was a curriculum. Suzuki demanded 70% localization within 5 years, then helped suppliers achieve it. They brought vendor development programs. They brought Kaizen. They essentially ran a master class in precision manufacturing for 400 Indian companies. The Gurgaon-Mainsar corridor didn't plan to become Asia's largest auto component cluster. It just happened to be where Maruti set up. When liberalisation hit in 1991 and the doors opened, something surprising happened. The auto component industry didn't collapse. It competed. Because 3 decades of forced existence had produced genuine capability. Hyundai arrived in 1996 and found a ready ecosystem. It didn't need to build one. Chennai became the Detroit of Asia, almost by accident. Now let's talk about cost, because this is where it gets really interesting. A 10 lakh rupee car contains roughly 1,000 kilograms of steel. That steel at raw commodity prices costs about 52,000 rupees. So the raw material is 5% of what you pay in the showroom. Where does the other 95% go? The single biggest wedge, 35% of the car's price, sits in components and sub-assemblies. Stamped panels, wiring, seats, bearings, glass. And this is precisely where India's labor advantage compounded. Labor is 30 to 40% of the cost to make these components. Multiply that saving across 400 parts, across 4 million vehicles a year, and the arithmetic becomes brutal for anyone trying to compete with India from a high-wage country. Steel multiplies 19 times from ore to showroom. Each transformation stage, from pig iron to hot-rolled coil, to stamped panel to subassembly to final vehicle, compounds value. And India captured the labor-intensive middle of that chain almost completely. That's the story. Robots. Robots look like mechanical products. Metal arms, joints, motors. You'd be forgiven for thinking that a country that makes cars can make robots. That intuition is wrong, and understanding why tells you something deep about how industrial ecosystems actually work. The most expensive part of a robot arm is not the metal frame. It's the joint. Specifically, something called a harmonic drive. 90% of the world's harmonic drives come from 2 Japanese companies. The tolerances involved are in the single-digit micron range. Japan spent 40 years building the machine tools, the metallurgy knowledge, and the institutional muscle memory to make these things. There is no shortcut to that. Then there are servo motors. High-performance servo motors need neodymium magnets, rare earth permanent magnets. China controls 85% of global rare earth processing. India has deposits on the Kerala coast. India does not have the processing infrastructure. So every servo motor in every robot assembled in India begins its life in a supply chain that India does not control. And then there are the chips. Automotive electronics run on older, more mature chip nodes, 28 nanometers, 65 nanometers, nodes where India might plausibly build capacity. Robot motion controllers and vision processors need 7 to 16 nanometer nodes. India has no fab there. Despite Tata and ISMC investments, a decade-long gap remains. In automobiles, the knowledge can be broken down. Welding is learnable. Stamping is learnable. Assembly is learnable. Suzuki could run a program and transfer it. Robot manufacturing requires control theory, precision materials science, embedded systems, and optical engineering to converge in a single team simultaneously. That knowledge doesn't transfer through a vendor development program. It accumulates over generations. And there's no volume to justify the investment anyway. India installs about 50,000 industrial robots per year. Japan installs that in a month. Without domestic scale, you can never justify the fixed cost of a precision harmonic drive production line. The Maruti flywheel never starts spinning. So what is India actually doing in robotics right now? It's integrating. Importing arms from Fanuc, ABB, KUKA, Yaskawa, and building the surrounding infrastructure. That's valuable. It creates real businesses. But it is not ecosystem building. It is sophisticated, value-added resale. India's genuine robotics advantage sits at the 2 ends of the stack. The very bottom, structural fabrication, metal frames, builds on existing capability. And the very top, software, AI, perception, fleet management, is where India is genuinely world-class. The brutal irony is that the software layer is only about 15% of a robot's cost. India is strong exactly where the margin is thin. The automobile story took 70 years. From railway workshops in 1853 to globally competitive component exports in the 2000s. That's not a policy cycle. That's a civilizational accumulation of capability. One forced decision, one JV, one cluster, one generation of workers at a time. Robotics starts that race today with Japan, Germany, and China, 40 to 60 years ahead in the hardest parts. The question India has to answer is not whether it can eventually build harmonic drives. It probably can. The question is whether it should, or whether the smarter play is to dominate the layer nobody else is focusing on, and let the arms stay imported for now. Path dependency is not destiny. But it is real. And understanding it is the difference between a strategy and a wish.